Course 3, Lesson 19 and 20, we're looking at polygons, and then Lesson 20 we'll look at triangles. Being able to identify the features of all of those things and how to name them. First, we need to know what is a polygon. Well, if we're talking about a polygon, then we are talking about a closed figure with straight sides. It has to be two-dimensional, and we have the same number of angles as sides. So if we look at some of these and decide, are these polygons or not? Let's start with one right here. Okay. The problem with this one, although it has straight sides, it's two-dimensional, it is not a closed figure. And same with this one. It's not a closed figure, but it also fails because we have curved sides rather than straight sides. And lastly, this cube. Although it has straight sides, it's closed, it's three-dimensional and not two-dimensional, so it's also not a polygon. Our triangle and our square, though, those fit the description. Those are polygons. More specifically, regular polygons, we have all the sides are the same length and all the angles are the same size. So if we were to look at these, let's say look at the triangle, we would say, okay, all of the sides are the same. Maybe they're each 2 centimeters. And all of the angles are the same. Well, a triangle has angles that add up to 180. So each of these would be 60 degrees. Okay. All of these, though, can be named based on how many sides they have. So let's look at those. 3 is a triangle, 4 sides is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 11 is a hendecagon, and 12 is a dodecagon. Well, you might be thinking, well, 13, what is that called? Well, 13, we would just call it 13gon, because anything above 12 sides, we just use the number and then add a gon at the end. So 15gon, 25gon, 32gon, 127gon. We just use the number and then add a gon at the end. So if we look at each of these, this one has 3 sides, so we're talking about a triangle. 5 sides, a pentagon. 9, a nonagon. All right, we have 8 octagon, 4 is a quadrilateral, 6 a hexagon, and this one has 7 sides, so we're talking about a heptagon. Moving right along, we can see we have 2 quadrilaterals right here, 2 rectangles, because they have those 90-degree angles. Okay, the only difference between these two is their size, right? They're the same shape, same angles, but this one's quite smaller than this one. We call this a dilation. Okay, when we're going from small to big, big to small, we can enlarge it, we can reduce it. We're talking about a dilation. Okay. When we talk about these shapes and compare them, we can compare them in a couple different ways. First, we can call them congruent figures. If and only if they have 3 things. Okay, first, we need the same shape. Are they both diamonds? Are they both arrows? Okay. 2, we need the same angles. Okay, meaning that all of these angles are the same. This one, okay, is congruent to this one. All right, we have the same angles in the shape. And 3, we have the same side lengths. Meaning that if this side is the same as this side, okay, this one's the same as this one, and so on and so forth. All of the side lengths are the same, so they're the same size. When we go to name them, we would say maybe this is ABCD. We'd say ABCD is congruent to WXYZ, and we would put this symbol in between them. When we have a couple of those things but don't have the same side lengths, we have similar figures. They're not congruent anymore, but they are similar, and we use the little squiggly to show similarity. So these are the same size, these are the same shape, they have the same angles, but they are not the same size. So similar figures, we need same shape, we need same angles, but these do not have the same size. Okay, not the same side lengths. Okay, but we could say that maybe this is ABCD, this is WXYZ. ABCD is similar to WXYZ. Because it's the same shape, we have the same angles. And soon we'll talk about their proportionality. Between one, we have proportional sides. If we look at some examples here, we have 4 triangles, okay? But we want to talk about similarity, congruence. Well, if we look at each of these, we can say, well, 1 and 4, those have the same shape, they're the same size, and they have the same angle. So 1 would be congruent to 4. We could say, all right, 1 and 2. Those have the same shape, the same angles, but they're not the same size. So I would say 1 is similar to 2. Okay. Similarly, 2 and 4 are similar. Okay. Unfortunately, 3 is kind of the odd one out. It doesn't have the same shape as everybody else, doesn't have the same angles, doesn't have the same side length, so it kind of is left alone. Here are some other examples that you can work through for yourself, okay, if you would like some extra practice with this idea. Now let's move on to some triangles. And the goal here is to be able to classify triangles not only with side lengths, but also with angles. All right, be able to find missing angle measurements and find the area of a triangle. So classifying triangles, we can do it in 3 ways: acute, right, and obtuse. And as you can imagine, those tell us what type of angles we're going to see. Acute, we're going to have 3 acute angles. Right, we're going to have 1 right angle, okay, which we can see right there. And we have 2 acute angles. Okay, I'm sorry, I can't spell. And obtuse, we have 1 obtuse angle. Okay, we can see it right there, which means that we would need 2 acute to finish off the triangle. Okay, so we can name them based on their angle measurements: acute, right, or obtuse. Everything will have 2 acute angles. It just depends on that third angle, if it's acute, if the angle is right, if the angle is obtuse. So if we were to look at this one, we would say, all right, I know that the sum of all angles in a triangle is 180. So if I have one that's 105, one that's 35, one that's 40, well, this 105 tells me that I have an obtuse triangle because that angle is over 90 degrees. All right, let's say we don't know one of the angles. Well, we know that an entire triangle is going to be 180 degrees. So I could say, well, 40 degrees and 42 degrees have already been taken up. So 82 degrees have already been taken up out of 180. I need to find the difference to figure out what that missing piece is. So we would say that is 98 degrees. Well, if this is 98 degrees, that's sure larger than 90 degrees, so this is an obtuse triangle. Okay, let's look at the next one. 42 degrees, something that looks like a box, which we know is a right angle, which tells us that it's 90 degrees, and we can use the same method. 180 minus combined what we have, which is 132, which means that my final angle is 48 degrees. This is a right triangle because of that 90-degree angle. Okay, so here are some other examples that you can try out. Also, try classifying it as acute, right, or obtuse. So if you want to stop the video for a second and try that out for yourself. But what we're going to do is 180 minus 128, which means 180 minus 128 is going to be 52 degrees, which means all of these are under 90 degrees, so this is an acute triangle. And then we look at my other one, 40, 60, and something. Well, that's 180 minus 100 has already been taken up, so we have 80 degrees left, which means this is also an acute angle, or acute triangle. Okay? Let's keep going. Because not only can we describe triangles by their angles, we can describe them by their sides. If none of the sides are equal, we call that scalene. If two of the sides are equal, we call that isosceles. And if all of them are the same size, we call that equilateral. These hash marks tell us which ones are equal. So if it has a hash mark and a similar hash mark, then those two sides are the same. Okay, and we can see each one of these sides has one hash mark saying that they are all the same length. Whereas the scalene has 1, 2, and 3, meaning all of those are different. Something to think about is, based on their sides, we also know something about their angles. If all three sides are equal, then the angles are equal. Okay. If two sides are equal, then two angles are equal. If none of the sides are equal, then all of the angles are different. Okay. All of those angles are different. So based on the side lengths, let's classify these. Well, we have 5, 7, and 10. If they're all different, then that means that it's scalene. If we have 4, 4, and 4, that means that those are all the same length. We have an equilateral triangle. And 6, 6, and 3, well, that means that 2 of them are the same, so I have an isosceles triangle. Okay. Now, practice putting all 5 of these, both with their side length classification and their angle classification. So if we look at number 1, those hash marks tell me that 2 sides are the same. So I know that this is going to be isosceles. And then I see that right angle, which means we're going to have a right triangle. So isosceles, right. Number 2. All right, these 2 sides are the same. So once again, we have an isosceles. But all of those angles are less than 90 degrees, which means I have an acute triangle, isosceles acute. All right, number 3, all of those sides are different, so I have a scalene and that right triangle. Number 4 is a scalene, but this angle right here, that's more than 90 degrees, so I have an obtuse. And number 5, equilateral, because all of those sides are the same, which means all of these angles are under 90 degrees, so I have an acute triangle. Okay. So we can classify a triangle in a couple different ways. The roof of a building in the drawing slopes 35 degrees. What's the measure of the angle at the peak of the roof? This is just like what we did earlier, saying I know a couple different measures, but I am missing one. So we do 180 minus what we have. Well, 35 and 35 is 70. So that means that that angle measure is 110 degrees, meaning that this is an obtuse triangle. And if you remember, if we have 2 of the same angles, that means that we have similar side lengths. Makes sense? So this is isosceles, obtuse. The other part of this and last part of this is being able to find the area of a triangle. We use the formula area equals base times height divided by 2, because it's really just half of a rectangle. So if we look at our first one, we have 6, 8, and 10. Well, important thing to know is what is the base and what is the height? Well, the base of our triangle and the height of our triangle are never going to be slanted. Okay, so in this case, we're talking about 6 and 8. So we do 6 times 8 divided by 2. The area of this is 24 inches squared. We're talking about area, so our units are squared. For the second one, remember we can't use a slanted height, okay? Or even this one, we can't use that because it's slanted. So we're left with 6 and 6. Because that 6 right here, that is the height. We need it to be perpendicular to the base, which means that it connects at a 90-degree angle. So we do 6 times 6 divided by 2, that's 36, divided by 2, which is 18 centimeters squared. And lastly, this funky triangle. Well, once again, we can't have slants, so this 8 is out. But this 8 is our base, and 7 is perpendicular, so it's our height. So we do 8 times 7 divided by 2. Well, that's 56 divided by 2, which is 28 meters squared. So figure out which one is your base and your height based on are they slanted or are they not. Okay, you're looking for things that are perpendicular. Here are a few other extra problems if you would like to practice. I hope this was helpful for homework and for studying.